Welcome to The Explainer. Today we're unlocking a powerful concept in Python. And honestly, it's something you already do dozens of times a day without even thinking about it. We're just going to teach our code to think that same way.
Right? I mean, you do this all the time. If it's sunny, I'll go out. Okay, I'm out. Then what do I wear? See? That's the chain of thought. And that multi-step thinking is exactly what we're going to teach our code. It's all about one decision leading right into the next.
So, this brings us to our first key concept, which is really the heart of our entire explainer today.
Yeah, exactly. It's really just if statements inside of other if statements. The best way to picture it is like a logic tree. You only get to check the smaller inner branches if you've passed the big main condition at the trunk. It's a hierarchy of checks.
Okay, so what does this logic tree look like in actual Python code? Let's get our hands dirty and break it down step by step.
So you see the flow here, right? You start with that big outer if. That's your first gatekeeper. Only if that condition is true does the code even bother to look inside at the next if statement. And that little bit of code at the very end, it only runs if you get past both gatekeepers.
All right, let's see this in action with a classic example. Can you drive? Look at the code. The first check, the first gatekeeper is age greater than or equal to 18? If the answer is no, the whole thing stops. But if it's yes, then and only then does it check the next condition. Do they have a license?
And of course, since age is 18 and has license is true, we get the green light. You can drive. But you can see how if either one of those was false, we'd have ended up in a totally different part of the code.
Okay, that's simple enough. But let's be real. Life isn't always a simple yes or no, right? So let's see how this builds, because we can handle way more options.
Take a look at this weather example. Here, we're combining nested ifs with elif. That just means else if. So the logic goes first. Is the weather sunny? If it is, then we dive deeper and check the temperature. But if it's not sunny, we can just jump to the elif and check if it's raining. See how you can start building these really detailed decision maps?
All right, you've seen how it works. Now it's your turn. Time for a quick challenge. I want you to play computer for a second and guess the output of this next bit of code.
Okay, here it is. X is 15, Y is 20. Take a really close look at the indentation. We've got 3 levels of nesting here. I want you to trace the path, check by check, and figure out what gets printed. So, what do you think? Is it going to be A, B, C, or D? Seriously, feel free to pause and think about it for a second before we reveal the answer. And the output is A. Did you get it? Let's walk through it real quick. First check, is X greater than 10? Yep, 15 is, so we go inside. Second check, is Y greater than 15? Yep, 20 is. We go deeper. Final check, is X plus Y greater than 30? Well, 15 plus 20 is 35, which is definitely bigger than 30. So boom, it prints A. Okay, let's put this all together and build the logic for something we use all the time, an ATM withdrawal. This is a perfect real-world test where nested logic is absolutely essential. First up, let's set the scene. Our user has an account balance of $1,000.
Okay, next they've got to prove who they are. They enter their PIN, 1, 2, 3, 4. This is going to be our first and probably most important security check.
And last, the reason they're here, the withdrawal amount. They're asking for $500. Okay, we've got all our variables. Let's build the code. So check this out. It's all about the order of operations. The code doesn't just check everything at once. It asks, is the PIN valid? Only if the answer is yes does it move on to ask, is there enough money in the account? And only if that's a yes does it finally check, is this withdrawal under the daily limit? You have to pass all 3 checks in order to get your money. Now this is powerful stuff. But you know what they say, with great power comes great responsibility. And nesting? Well, it can get messy, really fast. I mean, just look at this deep pyramid of if statements. It's sometimes called the arrowhead of doom for a reason. Yeah, technically it works, but trying to read it, or worse, trying to find a bug in there, it's a total nightmare. But there's a much better way. Look at the comparison here. Instead of that deep, nested mess, a lot of the time you can just use a logical operator like AND to combine your checks. See how the code on the right does the exact same thing as the code on the left, but it's so much cleaner, so much easier to understand at a glance? Okay, so we've covered a lot. What are the key takeaways you should remember when you start using this in your own code? Let's wrap it up.
First, nested conditions are awesome for complex, multi-level logic, but you've got to keep it readable, right? So try to keep it to 2 or 3 levels max, and always think, can I use something like the AND operator to make this simpler? And for sure, always test every possible path your logic can take. It's all about that balance between powerful logic and clean code.
And that's your explainer, wrapped up with a fantastic quote from B.B. King. You now have this powerful tool in your Python toolkit. The only question left is, what's the first complex decision you're going to teach your code to make?